Construction projects rank among humanity's most intricate and bold undertakings. They demand careful planning, deep engineering knowledge, and flawless execution. Yet history reveals numerous cases where errors in construction have triggered devastating collapses, massive setbacks, and even tragic loss of life. These failures often arise from insufficient preparation, flawed designs, substandard materials, or neglected safety measures. Below are 10 of the most significant construction blunders worldwide. Each offers a vital lesson for future endeavors. These incidents underscore the necessity of detailed foresight, thorough testing, and strict safety adherence in the construction field. The Leaning Tower of Pisa. The Leaning Tower of Pisa is one of the most iconic landmarks in the world, but its famous tilt was the result of a critical construction error. Built in 1173, the tower was designed to stand straight, but the soft, unstable soil beneath it, composed of sand, clay, and shells, caused the foundation to sink unevenly. As construction progressed, the tilt became more pronounced, raising concerns about the tower's stability. By the late 20th century, the tilt had reached a dangerous angle, prompting extensive restoration efforts. Engineers used innovative techniques, such as soil extraction and lead counterweights, to stabilize the structure. Today, the tower stands as a testament to both human error and ingenuity, reminding us of the importance of thorough geological surveys and foundation design in construction projects. Originally intended to stand tall and straight, the Leaning Tower of Pisa became a global icon due to its unintended tilt, caused by the soft, unstable soil beneath its foundation, which led to centuries of engineering challenges and eventual stabilization efforts that showcased human ingenuity in correcting monumental mistakes. The collapse of the Tacoma Narrows Bridge. The Tacoma Narrows Bridge, completed in 1940, is one of the most famous engineering failures in history. Its sleek, slender design made it highly susceptible to wind forces, a flaw that became tragically apparent when winds of just 40 miles per hour caused the bridge to oscillate violently. This phenomenon, known as aeroelastic flutter, led to the bridge's collapse within hours. Fortunately, no lives were lost, but the incident became a pivotal moment in structural engineering. It highlighted the need for better aerodynamic testing and design in suspension bridges, leading to innovations such as expanded decks, flexible materials, and advanced wind resistance calculations in modern bridge construction. Known for its dramatic collapse in 1940 due to aeroelastic flutter caused by wind forces, the Tacoma Narrows Bridge became a pivotal case study in engineering, leading to significant advancements in bridge design and aerodynamics to prevent similar disasters in the future. The Hubble Space Telescope Mirror Flaw. The Hubble Space Telescope, launched in 1990, was designed to provide unprecedented views of the universe. However, a critical error in the manufacturing of its primary mirror, a curvature mistake of just 2.2 microns, resulted in blurry images. This flaw, though minuscule, had a significant impact on the telescope's performance. In 1993, a team of astronauts successfully installed corrective optics, restoring Hubble's capabilities. Since then, the telescope has delivered stunning images of distant galaxies and nebulae. The Hubble incident underscores the importance of precision in engineering and the value of rigorous testing, even in highly advanced projects. The Hubble Space Telescope's initial failure, caused by a tiny but critical error in its primary mirror's curvature, was later corrected by a daring space mission, transforming it into one of the most successful tools for astronomical discovery, and underscoring the importance of precision in scientific instruments. The Montreal Olympic Stadium. The Montreal Olympic Stadium, built for the 1976 Summer Olympics, is infamous for its budget overruns, delays, and structural failures. Its ambitious design included a retractable roof, which proved to be a major engineering challenge. The roof's complexity and susceptibility to heavy snow led to a collapse in 1999. Additionally, construction delays meant that the stadium was unfinished during the Olympics. The project serves as a cautionary tale about balancing innovative design with practical engineering and realistic planning, especially in large-scale infrastructure projects. Plagued by budget overruns, construction delays, and a problematic retractable roof that eventually collapsed under snow, the Montreal Olympic Stadium stands as a cautionary tale about the risks of overly ambitious designs without adequate engineering and planning. The Chernobyl nuclear disaster. The 1986 Chernobyl disaster remains one of the worst nuclear accidents in history. While human error played a significant role, the design flaws of the RBMK reactor exacerbated the crisis. The reactor lacked a proper containment structure, and its unstable core design contributed to the catastrophic explosion. The disaster released massive amounts of radiation, impacting thousands of lives and contaminating vast regions. In its aftermath, the global nuclear industry reevaluated safety standards, emphasizing the need for robust reactor designs and stringent safety protocols. Resulting from a combination of design flaws in the RBMK reactor and human error, the Chernobyl disaster caused one of the worst nuclear accidents in history, leading to widespread radiation exposure and a global reevaluation of nuclear safety protocols. The Fukushima Daiichi nuclear disaster. The Fukushima Daiichi nuclear power plant in Japan faced a catastrophic failure in 2011 following a massive earthquake and tsunami. The plant's design, while earthquake-resistant, was inadequate to handle the tsunami's impact, which flooded the backup generators and disabled the cooling systems. This led to a meltdown in 3 reactors and widespread contamination. The disaster highlighted the importance of designing nuclear facilities to withstand extreme natural events and sparked global debates about the future of nuclear energy. Triggered by an earthquake and tsunami, the Fukushima Daiichi nuclear disaster exposed critical design flaws in the plant's ability to withstand natural disasters, sparking international debates on nuclear energy safety and disaster preparedness. The Sampoong department store collapse. In 1995, the Sampoong department store in Seoul, South Korea, collapsed, resulting in over 500 fatalities. The building had undergone unauthorized structural modifications, including the removal of critical support beams, which severely compromised its integrity. Warnings from engineers were ignored, and the use of substandard materials further weakened the structure. The tragedy led to stricter building codes and improved inspection practices in South Korea, emphasizing the dangers of neglecting safety standards in construction. A tragic result of unauthorized structural modifications, poor materials, and ignored engineering warnings. The Sampoong department store collapse claimed over 500 lives and led to stricter building regulations and safety standards in South Korea. The Sydney Opera House. The Sydney Opera House, an architectural masterpiece, faced numerous challenges during its construction. Its iconic shell-like roof design presented unprecedented engineering difficulties, leading to significant delays and budget overruns. Disputes between the architect and the government further complicated the project. Despite these issues, the Opera House was completed in 1973 and has since become a global symbol of modern architecture. Its construction serves as a reminder of the complexities involved in realizing visionary designs. Despite its status as an architectural marvel, the Sydney Opera House faced numerous challenges during construction, including engineering difficulties with its iconic shell design and disputes between the architect and government, ultimately becoming a symbol of perseverance and innovation. The John Hancock Tower. The John Hancock Tower in Boston, completed in 1976, experienced significant issues with its glass facade shortly after construction. The large glass panels were prone to detaching due to wind forces, posing a danger to the public. The building underwent costly renovations to address these flaws, including the replacement of the glass and reinforcement of the facade. The incident highlights the importance of considering environmental factors in architectural design and the potential consequences of engineering oversights. Renowned for its modern design, the John Hancock Tower faced significant issues with its glass facade detaching due to wind forces, requiring costly renovations and highlighting the importance of environmental considerations in architectural design. The Vdara Hotel Death Ray. The Vdara Hotel in Las Vegas gained notoriety for its death ray effect, caused by its curved glass facade. The design concentrated sunlight into a powerful beam, causing damage to nearby objects and discomfort to guests. The issue was later mitigated with coatings and adjustments to the glass. This incident underscores the need for architects to consider the environmental impact of their designs, particularly in urban settings with complex light interactions. Infamous for its death ray effect, the Vdara Hotel's curved glass facade concentrated sunlight into a harmful beam, causing damage and discomfort, and prompting modifications to mitigate the unintended consequences of its design. The Millennium Dome, O2 Arena. The Millennium Dome in London, now known as the O2 Arena, faced criticism for its poor planning, budget overruns, and lackluster exhibition content. Despite its bold design, the project struggled to meet public expectations and was deemed a financial and cultural failure. However, the structure was later repurposed into a successful entertainment venue. The Millennium Dome serves as a reminder of the challenges of managing large-scale projects and the importance of aligning design ambitions with practical execution. Initially criticized for its excessive costs and lackluster exhibition, the Millennium Dome was later transformed into the successful O2 Arena, demonstrating how ambitious projects can be repurposed to achieve long-term success despite early setbacks. The Vesuvius Submarine. The Vesuvius Submarine, part of the Italian Navy, was plagued by design flaws and construction errors. Issues with buoyancy, stability, and material quality rendered the submarine unsafe for operation. After several failed repair attempts, it was decommissioned in the early 1980s. The Vesuvius Submarine is a stark example of how poor design and oversight can lead to catastrophic failures, especially in high-stakes military projects. A failed Italian Navy project, the Vesuvius Submarine suffered from critical design flaws, including poor buoyancy control and inadequate materials, leading to its decommissioning and serving as a stark reminder of the importance of rigorous testing in military engineering. The Seton blunders show how small errors can lead to big disasters, but they've also made construction smarter and safer. Learn from the past, build for the future. Thanks for watching. Subscribe for more.